Ever wondered how disinfectants work and how they are classified? Our world is teeming with invisible life forms known as microorganisms. Some of these are beneficial, but others can cause illness and disease. That's where disinfectants come in. These unsung heroes of cleanliness are substances that kill or inhibit the growth of these harmful microorganisms. Whether it's in hospitals, kitchens, or your own bathroom, disinfectants play a vital role in maintaining hygiene and preventing the spread of diseases. But how do they work? At the most basic level, disinfectants destroy the cell walls of microorganisms or interfere with their metabolism. This effectively disarms the microorganisms, preventing them from causing harm. Disinfectants come in many forms and are classified based on their chemical composition. Each type has its own unique properties, advantages, and applications. Ready to delve deeper into the chemistry of disinfectants? Hold on to your lab coats. Now that we have a basic understanding, let's explore the chemical classification of disinfectants. To start, we have alcohols. These are organic compounds that feature a hydroxyl group. This group, consisting of one oxygen atom bonded to a hydrogen atom, is responsible for the germ-killing properties of alcohols. When applied, these disinfectants denature proteins and dissolve lipids, effectively killing a wide range of microorganisms. Next, we have aldehydes. Aldehydes are organic compounds characterized by a carbonyl center, which allows them to cross-link with amino and sulfhydryl groups in proteins. This interaction disrupts the structure and function of proteins within microbes, leading to their demise. Formaldehyde and glutaraldehyde are two common examples of aldehyde disinfectants. Moving on, we find phenols. These aromatic compounds have a hydroxyl group bonded to a benzene ring. This structure enables phenols to destabilize the cell membrane and denature proteins, causing cell death. Phenol itself was the first surgical antiseptic introduced by Joseph Lister, marking the beginning of modern antiseptic surgery. Lastly, we have quaternary ammonium compounds, often called quats. These are nitrogenous organic compounds that carry a positive charge. This charge allows quats to disrupt the cell membrane of microorganisms, leading to leakage of cell contents and eventually cell death. Benzalkonium chloride is a popular quat used in many household disinfectants. It's important to note, however, that not all disinfectants are created equal. Each class has its own strengths and weaknesses, with some being more effective against certain types of microorganisms than others. Factors such as contact time, concentration, and presence of organic matter can all affect a disinfectant's efficacy. Each class of disinfectants has its own unique properties and uses, but they all share the same goal: to keep our environment germ-free. And with that, we're ready to dive deeper into the role of phenols in disinfection. Strap in, because the journey into the microscopic world of germs and disinfectants is just getting started. Ever heard of phenol? It's more than just a chemical compound. This aromatic organic compound, known for its antiseptic properties, plays a crucial role in the field of disinfection. Phenol, also referred to as carbolic acid, is a white crystalline solid with a sweet, tarry odor. But its role as a disinfectant is what truly sets it apart. Phenol was the first disinfectant used in surgery, marking a significant turning point in medical history. In the mid-19th century, a renowned surgeon named Joseph Lister began applying phenol to surgical wounds. His goal was to reduce the risk of infection, a common and often deadly outcome of surgical procedures at the time. Lister's innovative use of phenol dramatically reduced post-surgical infections, saving countless lives and paving the way for the development of modern surgical practices. But the story of phenol doesn't end there. Its effectiveness as a disinfectant led to the development of the Phenol Coefficient Test, a method devised to measure the potency of other disinfectants. The test compares the effectiveness of a new disinfectant with that of phenol, establishing a benchmark or coefficient. This coefficient offers a standardized method to compare and classify disinfectants, providing a valuable tool for scientists and health professionals. The use of phenol as a benchmark testifies to its powerful disinfectant properties. However, it's worth noting that while phenol is highly effective, it's not without its drawbacks. It can be corrosive and toxic, especially when used in high concentrations. Over the years, safer alternatives have been developed, but phenol's historical significance and role in setting standards for disinfectants cannot be overlooked. In conclusion, phenol's journey from a simple chemical compound to a life-saving surgical disinfectant, and ultimately to the standard against which all other disinfectants are measured, is nothing short of remarkable. it underscores the transformative power of scientific discovery and innovation. The discovery of phenol marked a significant milestone in the history of disinfectants. Let's talk about the Phenol Coefficient Test, a classic method of evaluating the effectiveness of disinfectants. This test, also known as the Rydell-Walker test, or simply the RW test, has been a cornerstone in the field of disinfection for over a century. The test is named after its creators, Samuel Rydell and J.T.A. Walker, who developed it in the late 19th century. It's a relatively straightforward procedure. In essence, the test compares the killing power of a disinfectant against that of phenol, hence the name Phenol Coefficient. Now let's delve a bit deeper into the process. The test organism, usually Salmonella typhi, is exposed to dilutions of the disinfectant and phenol under identical conditions. The highest dilution that still kills the organism after a set exposure time determines the effectiveness of the substance. The disinfectant's phenol coefficient is then calculated as the ratio of its dilution to the dilution of phenol that achieves the same result. So why is this important? Well, the higher the phenol coefficient, the more potent the disinfectant. This means that it can effectively kill microorganisms at lower concentrations than phenol. It's a useful way to rank disinfectants and select the most efficient ones for specific applications. However, it's worth noting that the phenol coefficient test is not without its limitations. For instance, it doesn't account for factors like temperature, pH, and the presence of organic matter, which can all impact a disinfectant's performance. Additionally, it only tests against one type of organism, which may not represent the full spectrum of microbes a disinfectant might encounter. Despite these limitations, the phenol coefficient test has played a significant role in our understanding of disinfection. It has paved the way for the development of more potent and efficient disinfectants, and continues to be a reference point in current disinfectant research. So, the next time you use a disinfectant, remember the humble phenol coefficient test. It's a testament to our ongoing fight against harmful microorganisms and the relentless pursuit of creating safer, cleaner environments. The phenol coefficient test has paved the way for the development of more potent and efficient disinfectants. So, where do we find these disinfectants in our everyday lives? Well, disinfectants are everywhere, silently working behind the scenes to make our world safer and more hygienic. Let's dive into some of their key applications. Starting with hospitals, these are the battlegrounds where disinfectants fight their most crucial battles. In these environments, disinfectants are used to eliminate harmful microorganisms on surfaces, instruments, and even in the air. For instance, alcohols like ethanol and isopropanol are used to disinfect small surfaces, such as thermometers and stethoscopes. Now let's move to our homes. Here, disinfectants are used to maintain cleanliness and hygiene. They are commonly found in products like cleaning wipes, toilet bowl cleaners, and hand sanitizers. Quaternary ammonium compounds, also known as quats, are a popular choice for household disinfectants due to their broad-spectrum effectiveness against bacteria, fungi, and certain viruses. Next, let's talk about industries. In food and beverage manufacturing, disinfectants play a vital role in ensuring the safety of the products we consume. They're used to sanitize equipment, surfaces, and packaging materials. For example, peracetic acid is often used in the food industry because it's effective against a wide range of microorganisms and leaves no harmful residues. In water treatment facilities, disinfectants like chlorine and ultraviolet light are used to kill or deactivate harmful microorganisms in our drinking water. This protects us from waterborne diseases and maintains public health. And it doesn't end there. Disinfectants are also used in agriculture to prevent the spread of disease among livestock, and in personal care, products like toothpaste and mouthwash to control harmful bacteria. It's important to remember that different situations call for different disinfectants. Understanding their chemical properties and how they work is key to using them effectively and safely. Disinfectants are an integral part of our lives, ensuring our safety and hygiene. They are our unseen guardians, continuously working to protect us from the microscopic world. Now you know more about the chemistry of disinfectants and their role in our lives. We've delved into the chemical classification of disinfectants, dissecting how their unique properties make them vital in our battle against harmful microbes. We've explored the pivotal role phenol plays in this sphere, acting as a benchmark in the disinfection world. We've also demystified the phenol coefficient test, a crucial tool in determining the effectiveness of a disinfectant and how it's used to keep us safe. Lastly, we've seen the practical applications of these disinfectants, highlighting their importance in healthcare, food safety, and even in our homes. The science behind disinfectants is a testament to the incredible world of chemistry, a world that's constantly evolving, and one that we are all a part of. So let's keep learning, keep questioning, and keep discovering together. Subscribe for more because you won't find me later. Stay curious and keep exploring the fascinating world of chemistry.